video, we're going to take a look at weight and gravitational potential energy. First though, we need to understand what gravity is. You can think of gravity as a force of attraction between two objects, with the size of that force depending on the mass of those two objects and how far apart those objects are. So for small objects, like apples or even buildings, the gravitational force of attraction is so tiny it's as though it doesn't even exist, because they both have relatively low masses. And the same goes for very large objects that are really far away, like Jupiter, because the distance is so far. However, for very large objects that are also close by, such as the Earth or the Moon, gravity is felt far more strongly and can have a big influence over nearby objects. We call this field of influence around an object its gravitational field, and the strength of this field is called the gravitational field strength, which we show with the letter G. For Earth, this is around 9.8 newtons per kilo, while for the Moon it's just 1.6, because the Moon is a lot smaller than the Earth. So whenever an object comes into a gravitational field, it experiences a force of attraction. And in physics, it's this force that we refer to as an object's weight. To calculate an object's weight, we take its mass and multiply it by the gravitational field strength, as this formula will tell us exactly what the force of attraction is. For example, if a person with a mass of 60 kilos was on Earth's surface, then they would experience a force downwards towards the center of the Earth of 60 times 9.8, which is 588 newtons. So we could say that their weight is 588 newtons. Now, you've probably noticed that this isn't how we normally talk about mass and weight in real life. Normally, we'd say that we weigh 60 kilos, not that we have a mass of 60 kilos. This is just one of those times where the technical physics terms are different to everyday language. And you basically just need to be aware of this difference and know that when you do a physics paper, weight and mass are two different things. With mass being an intrinsic property of an object, while weight is the force acting on it in a gravitational field. So to lift up an object and overcome this force of gravity is going to require energy or work. And this energy that we use will be transferred to the object's gravitational potential energy store. The formula for gravitational potential energy, which can be written as EP, is that EP equals mgh, or mass times gravitational field strength times height, with the units being kilos, newtons per kilo, and meters. And as gravitational potential energy is a form of energy, it's measured in joules. As an example, let's imagine we have an apple with a mass of 100 grams, and we throw it 3 meters up in the air. What is its gravitational potential energy? The first things we need to do are write out our equation and check that everything's in the right units. So we need to convert the 100 grams into kilos by dividing it by 1000 to give 0.1 kilos. Next, all we need to do is plug these values into the equation. So our calculation becomes 0.1 times 9.8, which is the gravitational field strength for Earth, times 3, which is our height. And this gives us 2.94 joules as our answer. Now, to very quickly recap, the key takeaways from this video are that gravity is a force of attraction between objects, with the size of that force depending on the mass of those objects and how far apart they are. That weight is equal to mass times gravitational field strength, which is 9.8 newtons per kilo here on Earth. And finally, that gravitational potential energy is denoted by EP and equals mass times gravitational field strength times height.